Hello there and welcome to Lower 6th Further Maths A-Level. This is the practice paper for the pure part of the syllabus, taking questions from June 2012. Here we're on question 5, a three-dimensional rotation question, a matrices question here, so I've added this question in myself. This wasn't on the previous syllabus. So we're looking to find matrix A that's representing a clockwise rotation 120 degrees around the y-axis. So if we imagine how this looks on the three-dimensional coordinate system, where we have x here, y here, and z up here, and if we are effectively standing at this 0, 0 coordinate here, looking down the y-axis, what we're going to see is that we want a rotation 120 degrees around the y-axis that way. Now as we stand here, what we're going to see is a zx axis that looks like x will be on the left hand side of this person and z will be on top. So what we're going to do is we're going to reduce this problem down to a two-dimensional problem, just looking at the z and the x-axis. We'll include the y-axis in the matrix later, but we'll start here. But we have to start with the x-axis in the positive direction on the left, and the z-axis will be positive going upwards. So we'll start with our 1, 0 coordinate, that's this coordinate here. We'll give this a coordinate A, and we'll give this a coordinate P to save the confusion of matrix A. And we'll give this a coordinate Q here. This is the coordinate 0, 1. So this coordinate here is 1, 0 because the left hand side this time is the positive direction. So we're going to have the matrix A transformed by the coordinate P and the coordinate Q will give us our destination, our final coordinate matrix, our image coordinate matrix. So what we'll do then is we'll rotate it 120 degrees and see where our coordinates end up once we've applied matrix A. So coordinate P will rotate 90 degrees clockwise round and then another 30 degrees. So P is approximately going to be here with a 30-degree angle here. And Q, we're going to do exactly the same thing, rotate 90 degrees round and then another 30 degrees round. So we're going to end up here at the point Q with a 30-degree angle in here. Now remembering that these distances from 0 to P and 0 to Q is 1, the coordinate of P and the coordinate of Q is just going to be either a sine or a cos. 1 times a sine or a cos. So for the x-axis here, it's just going to be sine of 30, which is a half. But remembering that left is positive, in this case right is negative, this is actually going to be a negative a half. For the y-coordinate, we're going to use this left-hand side of the triangle here. So that's just going to be the cos part of 30. So that's going to be root 3 over 2. For Q, this is going to be a right angled triangle with a 30-degree angle inside it. So for the x-axis first, it's going to be the cos part of 30, which is root 3 over 2. And as right is negative in this case, it's a minus. And for the y-coordinate of Q, that's going to be the opposite part of the 30-degree angle. So it's just going to be a half, and seeing as it's on the bottom of the z-axis, it's negative a half. Okay, so this is what the matrix A would be if it was just in 2 dimensions, just working with the x and just working with the z-axis. Now we bring back in the fact it's a 3-dimensional matrix here, and it's going to be stable around the y-axis. So because of that stability around the y-axis, it's going to have 0, 0, 1 and 0, 0 in those y positions. And then we're going to fit in this matrix A around this these stable points here. So it's going to be minus a half, minus root 3 over 2, root 3 over 2, and minus a half. Okay, so that's matrix A. So that's for part A done. Part B is to now find the image of this coordinate under this matrix here. So it's going to be minus a half, 0, minus root 3 over 2, 0, 1, 0, root 3 over 2, 0, minus a half, multiplied by the coordinates, and then we'll just multiply out the matrix to work out the image of the coordinates. So to work out k prime, we multiply out these matrices, so it's going to be minus a half k, 0 times 1 minus k, and minus root 3. The 2's will cancel, so it'll just be root 3k. The next part is going to be 0 times k, 1 minus k, and 0 times 2k. The next part's going to be root 3 over 2k, and then 0 times 1 minus k and minus k, because the 2's will cancel. So there we are. Let's tidy up this coordinate a little bit. So it's going to be negative of over 2 plus root, no, sorry, 1 plus 2 root 3, lots of k. 1 minus k will come next, and then it's going to be root 3 minus 2 over 2, lots of k. So that's the simplified version of the coordinate there. Great, 6 marks for that question.